Okay, so what we're going to talk about today is the sum of a finite arithmetic sequence, okay? So it's actually a fairly simple process, all right? So first off, what you want to do is you just want to pause this video and write down this formula, okay? So to find the sum of a finite arithmetic sequence with n terms, so you realize here this is not an infinite sequence, okay? We're not, going on forever. We have a specific number of terms that we're going to add all together, okay? Now obviously, let's go ahead and let's look at this example 5. All right, hopefully you already wrote this down. That's a formula that we're going to come back to. But let's just go ahead and look at this example 5. It says, finding the sum of a finite arithmetic sequence, find the sum. And then it gives us 10 terms, okay? So the first term is term number 1, okay? And then the last term is term number 10. All right? I mean, you can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, obviously, you could grab a calculator, turn it on, and you could do 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19, okay? And you could get that the sum is 100. So you know that the sum of all this is 100, but that was a little time consuming, okay? It was a little time consuming, and there's just a better, faster way to do it if you understand this formula, okay? So let's go back to this formula fast, all right? This formula comes from a man named Pascal, I believe. I could be misquoting the person, but the story is that he had a substitute in school one day, and the sub, I guess, just didn't want to teach, and so instead the sub just passed out busy work. And I think he put it on the chalkboard. I don't think there was really paper at this point in time. I could be wrong about that. I'm not a historian. All right. And the student, Pascal, he found that you can find the sum of any number of terms by using this formula. He figured it out. So the sub had them adding a whole bunch of numbers together. And it was just time-consuming, busy work. It was a waste of time. And he found out, as a small boy, that you could just simply find the sum of any number of terms by saying the number of terms divided by 2 times the first term plus the last term. Okay, so what this S of n stands for, the sum, okay, of any number of terms. So in this case, it's the sum of n terms. Now, we get specific numbers later on, like instead of doing n terms, we say like 10 terms, and we'll do that in a second. All right, n is the number of terms, a sub 1 is the first term in the sequence, a sub n is the last term in the sequence. All right, so let's go apply this formula to this right here, because we know what the answer should be. The answer should be 100. So then for this, the way we would apply is we would just simply take, all right, how many terms was there total? There was 10, so I would do 10 divided by 2 times, all right, what's the first term? First term is 1. What's the last term? The last term is 19, so 1 plus 19. And now you could plug this all in a calculator at this point in time if you want to, but you could also just do 10 divided by 2, which is 5, 1 plus 19, which is 20, so 5 times 20 is 100. So the sum of these 10 terms, that's an S, so the sum of these 10 terms is just simply equal to 100. All right? Okay, let's try another example. So our next example, example 7. Finding a partial sum of an arithmetic sequence. All right, so we're finding a partial sum. So what does that mean? Well, that means that this sequence actually keeps going, but if you read the question, it'll tell you how many terms it wants you to sum up together. It says find the 150th partial sum. So that means it wants you to add 150 of these terms together. 5, 16, 27, 38, 49. And it says it's arithmetic. This only works when it's arithmetic, okay? So I need to add the first 150 numbers together. I don't even know the first 150 numbers. So it's not like I could just grab a calculator and keep adding on forever, but I don't really want to do that. That seems excessive. You definitely can, but I don't want to. That seems excessive. All right, so instead we're going to use this formula. All right, so this formula says sum of n, so sum of 150 in this case, is equal to, all right, the total number of terms. How many terms was the total? 150. Divided by 2 times the first term plus the what? I don't know the last term. I don't know the last term. That's a problem. Okay, so there's two ways I can approach this problem. Okay, so here's what I'm going to do. I'm going to approach this problem the first way, and then I'm going to approach this second problem the second way. All right? The first way I would approach this problem, in order to find the last term, is I would just do what I did yesterday. I would say, okay, I need the 150th term. I know that a sub n, you should remember that you can find any term in the sequence by knowing the explicit formula. Okay, y'all remember why we talked about finding explicit formulas? Explicit formulas allow us to find any term we want in the sequence. I know that I can find the explicit formula for any term by just simply saying a sub 1 plus d times n minus 1. Okay? So, I know what a sub 1 is. It's simply 5. I can find d pretty easily. Just simply say, okay, 5 to 16, 16 to 27. It seems like I'm adding 11 each time. So d is 11 times n minus 1. Okay, so then that gives me a sub n is equal to 5 plus 11n minus 11. And then I can say a sub n is equal to 5 minus 11 would be negative 6. So I'm just going to say 11n minus 6. All right. So now I want to find the last term. So if I'm finding the first 150 terms, what is going to be the last term? If I'm summing up the first 150 terms, what is going to be the last term I need to know? Hopefully you realize that's pretty obviously I'm going to need to know the 150th term. That would be the last term I need to find. So the 150 term is just simply 11 times 150 minus 6. Cut down here. I don't know if y'all can see this, but I can't write over my face. So 11 times 150, we can do that in a calculator. So we turn the calculator on. 11 times 150, and then I need to subtract 6. Subtract 6. I get that the 150th term is 1644. So a 150 is equal to 1644. Okay, so now I can take the 1644 and I can plug it in right here. And now the rest of this is a simple calculator problem. All right, so I can just simply say 150. So now I can actually finish finding the sum. That's what I'm doing. I'm actually finishing finding the sum because I found the last term. Okay, remember the formula. It's the first term plus the last term times total number of terms divided by 2. The total number of terms is 150 divided by 2 times the first term, which was 5, plus, and then they didn't give us the last term. The last term would be the 150th term. So instead, I had to find that term. So then I say 150 divided by 2 times 5 plus 1644. Press enter, and I get that that's the sum, 1, 2, 3, 6, 7, 5. So if I was to add all first 150 terms together, I would get, I already forgot the number. I would get 1, 2, 3, 6, 7, 5. I would get 1, 2, 3, 6, 7, 5. So 123,675. Okay? Now, that is one way to approach this problem. It's a completely okay way to approach this problem. Alright, there's nothing wrong with what we just did. We're going to do the second problem in a very similar way, but not exactly similar way. Okay? So let's do the next problem here. Let's erase all this. Okay. Now, this says evaluate the series. Okay? And it tells us that for the total number of terms I'm going to get are 16 terms total. So I'm adding all these together. So I will continue to add these together to infinity. But it doesn't want me to do that till infinity. This question just wants me to find the addition if the first 16 terms are added together. So it just wants me to sum, that's an S. That really is an S. It just wants me to sum the first 16 terms. So the sum of the first 16 terms would be the total number of terms, 16, divided by 2 times the first term plus the, all right, once again, I need the last term. This time I don't know the last term. I do not know the 16th term. I need to find the 16th term. So last time we found the 16th term by creating an explicit formula. let's go back to that for a second. Let's remind ourselves, what is an explicit formula? Well, it allows me to find any term in the sequence, and it's simply a sub n is equal to a sub 1 plus d times n minus 1. So wait, do y'all see how this is a sub n and this is a sub n? So this says a sub n equals this, so that means I could take this and I can plug it in for a sub n right there. So now instead I have s sub n, so the sum of the n terms, is equal to the n terms, total number of terms, n, divided by 2, times the first term plus the first term times, I'm plugging this guy in, so I add a sub 1 again, plus d times n minus 1. Now, let's see if we can't do some finagling and see what happens here. Okay? Well, if I have a sub 1 and a sub 1, what is a sub 1 plus a sub 1? Hopefully you realize that that's simply 2a sub 1. So 2a sub 1 plus, distribute the dn. Well, actually, don't even distribute the dn. Don't do that. Sorry. Don't do that. Just leave it as d times n minus 1. Because I'll know what d is, because, you know, I can tell, I can look at it. And then I know what n is. N is the total number of terms. Okay? And I already know the first term. So do y'all realize that now I can say that the sum of any number of terms is equal to the nth number of terms divided by 2 times 2 times the first term plus the common difference times n minus 1. Alright, so let's do that. 2 times the first term, so the first term is 20. That's a 20. Plus the common difference. Okay, what is the common difference? 20, 27, 27, 34, 34, 41. The common difference is 7. Times, how many terms do I have total? 16. What is 16 minus 1? 15. So put 15 right here. And now I can just jab all this in a calculator. And so I could say, now you might be wondering, hey, what is the advantage to using this other way of doing it? Like, it seemed like it took us a while to get there. But let me ask you a question. Now that you know this, do you actually need to reconstruct it every time? Like, do you need to go all the way back and plug it back in? No! You can just use this formula right here. Alright? You can just use this formula right here. Alright, so I can say 16 divided by 2 times 40. I mean, 2 times 20 is 40. But I'm not entirely sure what 7 times 15 is off the top of my head. I think it's something like 85, but I'm not sure. I don't want to mess up. So I get 1160. So the sum of all of the first 16 terms of this series is 1160. Alright? Okay, so I started off all this giving you the definition of how to find a sum. Alright, so I gave you the formula, not a definition, sorry. I gave you the formula on how to find the sum. But we never actually talked about the definition of a series. Like, what is a series? Okay, well, I said several times that was the sum of, but there's actually some fancy math notation. Alright, so you see this big looking Z thing? Alright, this is called epsilon. Okay? And anytime you see this, it's a Greek letter called epsilon. And it stands for the sum of, okay? And so what it means is that you sum up over this entire, like, see the series over here? You are summing up this series, okay? So anytime you see this notation right here, it means that you are taking the sum from the first term, so that's what I equals 1, that's what that means, okay? It means the first term, to the nth term, so that's our last term, okay? So the nth term stands for our last term, okay? And this a sub I, this stands for our explicit formula, okay? Explicit formula. So once again, anytime you see this, guys, it's literally what we just covered. We just walked over it, okay? However, I just want to make sure you understand the notation. Alright, so I'm still going to do one more example. I know this video is kind of getting long, but I'm going to do one more example showing you how to do what we just did, just using this notation instead. Alright, this notation just stands for the sum of a math series, of an arithmetic series, sorry. Alright, again, you just start with I equals 1, so that means they want you to start with the first term, go to the last term, and use this explicit formula to get those two terms. Okay? So, sorry, I sent out a remind and now I'm getting a whole bunch of responses. Alright? So, Let's do this. Oh, I forgot to erase this as I was getting ready. Just pretend you didn't see any of that. Sorry about that. This is super unprofessional. Okay. But I'm not going to go back and edit it because I'm too lazy. All right, so let's read what this example is telling us. This example is telling us it wants us to sum up this explicit formula from the first term to the 35th term. Okay, so once again, you should remember that to find a partial sum, S sub n is equal to n divided by 2 times the first term plus the last term. Okay? And if for some reason you don't know the last term and you just don't want to use this formula, you could also write that the sum of any number of terms is equal to the number of terms divided by 2 times 2 times the first term plus d times n minus 1. Now, here's the problem. Here's the problem using the second one. Hopefully you can look at it and see the problem. But from this given information, do I know D? Do I know the common difference? No, I don't. Now I could find it. It would not even be hard to find it. I could find it by just figuring out what is the first term, what is the second term, and subtracting the two. Okay? But it's also very easy to use this explicit formula to find the first term and the last term. Okay? Because we know the first term is, you just plug in 1 for k. So a sub 1 is just simply equal to 5 times 1 minus 2, which that is just simply 5 times 1 is 5, 5 minus 2 is 3. Boom, there's your first term. Then I can find the 35th term by I already have the explicit formula. I don't have to find it. It's already given to me. 5k minus 2 is the explicit formula. So I can just say 5 times 35, that's a 35, okay, 35 minus 2. Which that is simply, let's see, 5 times 35, 5 times 30 is 150, 5 times 5 is 25, so 150 plus 25 is 175, 175 minus 2 is 173. So now I can find the sum of this pretty easy. I'll just say the sum of all 35 terms is equal to 35 divided by 2 times, now I know the first term, it is 3, plus the last term, that's what a sub n stands for, which is 173. Alright, so now I can just grab my calculator, I can type in, if it ever wanted to turn on, I can type in 35 divided by 2, divided by 2, times, well, what's 3 plus 173? Blah, blah, blah. What is 3 plus 173? It's 176. And so 3080. So the sum of all 35 terms, if I just kept adding them together, is 3080. Alright? Alright guys, I hope this video was helpful. Let me know whatever questions you have. Okay.